These are our notes on similarity. So with these similarity notes, we first have this first term here, congruent, which we're familiar with, but that means it has the same shape and size, or the same shape and size as the mirror image of the other. For similar, it means that the figures have the same shape, or one has the same shape as the mirror image of the other. Okay, so we know that two polygons are similar, and this is the symbol for similar, if corresponding angles are congruent, and also if corresponding sides are proportional, which means that they have the same ratio for each side. So in this first example, we can see that in these figures, it's saying that ABCD, so ABCD, is similar to EFGH. So we should be able to answer these following questions from that. So it's saying the measure of angle E would be equal to, so if you look up here, the measure of angle E should be equal to the measure of angle A. And we know that because of this statement. Here's E and here's A. And since we already know that angle A is 53, then we know that angle E would also be 53. Number 2 here says AB over EF equals AD. So here's AB, and it's saying over EF equals AD over EH is what we should have written down here. Segment EH. For our next one, measure of angle B. So here's angle B, and we know that the measure of angle B, we're not sure yet, but we do know that it is similar to angle F. And so we can say that angle F equals 127, so therefore angle B would also equal 127. And we can also write on here, measure of angle F. For the last one, segment GH over segment CD is equal to segment, so again, here's GH, so that's equal to, so again, GH over CD is equal to FG over segment BC. In this next example, it's asking us, is triangle ABC similar to triangle FED? And we have to justify. So the way that we're going to do that, the way that we test this, is we have to find our sides that would be similar. So I'm going to start off with AC, and I'm going to say if I had AC and that's over FD, you have to come up with your side that would be equal to that. So AC and FD, I can also look here, AC and FD. So I'm going to put FD here. And we would set those, see what we can find. So AC is 18 and FD is 24. So this would reduce down to 3/4. And then we could take AB, so AB over FE, and when we plug in those values, AB is 15 and FE is 20, and again that would reduce down to 3/4. And then we could take BC, so here's BC over ED, and when we find those values, BC is 12 and ED is 16. So again, that would reduce down to 3/4. So we see for each of these, when we set the sides up and we find the similar sides, the similarity ratio, so we'll just write that. Similarity ratio is 3/4. So we would say, yes, these two triangles are similar, and that's how we would justify it. On this next example, it wants us to test these two polygons here. So again, we're going to do the same thing, find our similar sides. So I can see that DC would be similar to or equal to HG. So I'm going to write that right here. I would just take my 8 and divide it by the 2. And then I've got to find my next similar side, and we could reduce this down to 4. And then for our next similar side, we would have AB, we can see, would be equal to EF. So I would write that down, 12 divided by 5. And already I can see that no, those, we would not have the same similarity ratio for those. So for this, we could say no. We could not prove that these two were similar. So for our similarity statement here, I just put A, B, C, D, and we would normally say is similar to E, F, G, H, but I drew a line through it saying that those would not be similar, and I just put no down here as well. Again, on this next example, it wants to know, are these figures similar? Write a similarity statement and identify similarity ratio. So first of all, I'm going to write the similarity statement. So we could say for this one, triangle ABC is similar to triangle YZX. So we said ABC is similar to triangle YZX. And now we have to test it to see if that's true. So we're going to set up our sides. So the first one I'm going to take is right here. So I would say 21, and I want my other side that would go with that. So 21 divided by 7. And so we know we can reduce that down to 3. And for the next side, we could take AB. And so we're just going to put 6 and divide that by 2. So again, that reduces down to 3. And then for our last side, just to test to make sure that they all match up, we can take this side, 27 divided by 9. And again, that's going to give us 3. So we can say, yes, these figures are similar. And for our similarity ratio, we can say is 3, or you could also say 3:1. Okay. On this example, it is telling us that these are squares, and it gives us the information for one of the sides. So again, if we want to figure out if these are similar, we can just say, we know that these sides would be the sides we could match up. So we can say 6/10. And when I look at this, we know that this is a square, so all of the sides are going to be congruent. So technically we could say 6/10 is going to be equal to 6/10 because this side's going to be 6 and this side's going to be 10, 6 and 10. So what we would give for our answer on this is yes. These would be similar. When we have to solve for a variable, we're going to do it the same way. So looking at these two figures, I can see here's my similarity statement. So we can take AB, I'm going to say Y, over DE, which would be 1, equals, and then we can take our AC, 5, and since we have AC, over DF, and DF is 2. So when we solve for this, when we cross multiply here, we're just going to get that Y equals 5/2. And that can reduce down to 2.5. And that would be our answer for our Y variable. On this last one, you can see our similarity statement here. It's saying that ABCD, so ABCD is similar to LEFG. FH, and it wants us to solve for the missing variables. So I'm going to pause the video here, and you can go ahead and see if you can solve for each of the missing variables. And you can see there that we have a y, we also have this z, and we have an x that we have to solve for. So I'm going to pause the video, go ahead and see if you can solve for those three, and then we'll compare our answers. Alright, so when we solved for y, you can see how I set it up here. I just took my 3y over 5, and then I set that equal to 9 over 3, and when you solve for that, you should have gotten that y equals 5. When we solved for our z, I took my z minus 4 and divided that by the 21, and then I set that equal to the 3 divided by 9, and when you did that, you should have gotten that z equals 11. And for the last one, for our x value, we said x divided by 3 equals 9 divided by 3, and that should have given you 9. So your x value should be equal to 9. Hopefully you got the same answers.